So we're back with this thing, and actually it's working really well. I know the title suggests it's not. It was a funny play on words. Anyway, so yeah, it's working okay. I've only had one visit from a cat in about 2 weeks, I think, and it didn't crap in the garden, so that's good. I just saw it in the garden and it was lurking around. But yeah, they haven't been going in the garden, which is great. So this thing seems to be doing its job. I don't have one in the front garden, so that is now a toilet, unfortunately. Put some chicken wire down, it seems to have worked. I don't like going on it, but occasionally one's brave enough. Anyway, the reason I pulled this out again is because I wanted to talk about its performance. I did say that I didn't know how long the batteries would last. Well, the 800 milliamp hour batteries don't last very long. They're rubbish little solar batteries. Their capacity isn't 800 milliamp hours really. And they seem to carry a lower voltage most of the time. However, the ones I've got in this are a higher capacity. So let's just get this open, shall we? They're a high capacity. I think they're like 2,100 milliamp hours, and they've been in there for a few days, I think. I have to keep replacing it, the batteries that is, or rather recharging them every week or so. Not or so, because that would suggest more than 1 week. I mean about every week, or when I remember to go out. I don't think it needs to be on every single day. It's just enough to keep the cats pissed off. So we've got these nickel metal hydride batteries in here. Let's have a look at what the voltage is now actually. Let's just bring a multimeter in and measure that. So we've got 3.8 volts and individual batteries 1.285, 1.246, 1.271. These batteries are old, really old. So probably about 5 or 6, maybe even more than that years old. They've been recharged or discharged and recharged many, many times. So they're probably coming to the end of their usable life. They're certainly not the capacity stated on here. However, I recently pulled this back in to recharge it and forgot that it had this USB to DC jack cable that came with it to plug it in here. And so I thought, do you know what, that's easier. I won't have to unscrew the back. I can just plug this in. And what happened when I plugged it in, I will show you. I left it for about, I don't know, 5 hours, and I thought that'll do. That'll be fine. Let's see if you can see that. Maybe you can, maybe you can't. It looks roughly in focus. So let's plug it in. So we're at 5 volts on this adapter here. And we're drawing what? 10, 20 milliamps. If you assume there's a slight crap factor about this reader, we're still not that far off that figure. It's not going to be magnitudes higher. So 10 or 20 milliamps. It could be 30 milliamps, but 20 milliamps is pretty rubbish for a charge rate for batteries that are 2,100. And the other batteries are 800 milliamps that came with these ones. So, you know, what's that? If we just look at it from a charging perspective, I've got my little Commodore calculator here. So let's say it's not going to use all 800 of those milliamps. Let's say it uses 700. 700 divided by, let's say it was 25 actually, not 30. Let's not go for that. So 25 equals 28 hours divided by 24. So we're going to get, what did I just do there? Let's do that again. So what did I say? 700 divided by 25 equals that. And then divide that by 24 gives us 1.116, whatever. It's over a day basically to charge those batteries. That's a long freaking time to be waiting around. And if it was these 2,100 milliamp hour batteries, which have about 1,800 capacity these days, so still good capacity, divided by 25 equals 72 hours, and then divide that by 24. We've got 3 days to fully charge those. That's shocking. So I thought we'd have a look inside and figure out why that is, and whether that's intentional or if it's just not connected. It's possible. So first off, let's take these batteries out, put these screws aside. Now, it's a curious sort of problem to have, isn't it? That you have this solar panel on top, this glass solar panel here. It is actually glass. I'll show you in a minute when we get into this. So a glass solar panel on top, which charges these batteries at an unknown rate. And I say unknown rate because it hasn't really been sunny enough at a time when I've been available to test it. So I haven't been able to disconnect the solar panel from the board just to find out what kind of current we're looking at. Even if it was short circuit current, I haven't been able to look at it, or even the voltage. When we looked at it before, we were able to discern that the solar panel went straight into the batteries via a diode. So it's got to be a safe voltage. So probably, I would guess around 4 volts coming out of that solar panel, probably peaking around 5, maybe even up to 6, but I very much doubt it. It's probably going to be 4 or 5 volts. Okay, we're not quite in. I can see can I see what the problem is? We've got something else connected. Is there another? I've missed a screw. There we go. So we're in. Now, I haven't had this apart for a little while, so let's have a little look. There's a bit of green going on around here. Was that there before? It doesn't seem to be mold. There's certainly no corrosion on here. It's been out in wet weather. It's been out in very hot weather as well. So it's dealt with it reasonably. Yeah, there's no sign of anything bad. So from the DC jack, it's very difficult for you guys to see because it's all like a spider's web, but from the DC jack we've got the white wire and the blue wire. And the white wire is coming down here to what is ground. It's the same ground as is on the batteries and the ground on the solar panel. And then blue is our positive. So it's a center pole positive, and that goes into an IC. Let's see what that is. I'm gonna have to take this board off, I think. I can't quite read it. So let's take this off and then we'll have a look. See, there's a lot of chips on here and I don't really know what they all do. And the reason for that is it's not really a familiar circuit to me. I've used PIR sensors before, so my assumption is that the bigger chip on there is for the PIR sensor, and then the smaller chip is probably driving all of those LEDs. However, I can't be sure of that. It could be that smaller chip is the one making the sound on the speaker, so the one driving like a PWM signal or something like that. Although it is an ultrasonic, so it may need a specific type of chip. Again, not something I'm massively familiar with. We're sort of in. I've just realised, this is further than I got last time. If you remember, I took it apart just to have a look inside. But it's got potentiometers on the outside that need to come off. There we go. Good. And we're in. Okay, so there's our circuit board. Let's see if I can zoom in and do a bit of focusing on that, shall I? So there's our board. We've got the PIR sensor just here. It looks awesome, like some kind of SSD or something. That's a D2032. It's upside down for me, so I can't read it. And we've got a couple of our pots here. This one is a 10K pot, and this one's a 100K pot. And lots of capacitors here. Ugh, sticky. Is that an inductor there? I think we spoke about this before. That's for driving the ultrasonic or piezo speaker or whatever it is. Now our power's coming in here, just there. So let's have a little look around. In fact, I'm going to draw this out, so bear with me. So it looks like we've got some batteries there on, so these are our batteries that are going in. You forgive me if I speed this up. And so we've got 3 batteries. That's roughly, that's meant to be a tilde, 4.5 volts. And so they're 3 times AA. Now we have a solar panel in circuit. That one's an easy one because I already know what that is. So we've got our solar panel here and rays going onto it. So it just signifies that. And all we have, it looks like, is 2 diodes. We've got 2 diodes on the board. One is for the solar panel, and that's an SS14 it looks like. And then another one going to the batteries, which is another SS14. And that comes from goes through a resistor. So we've got a resistor here, and that is a 120 ohm SMD resistor. Now from that, it's interesting actually, because we've got a chip on the board. And it is, I'm not going to draw it, I'm just going to draw it as a block, if that's okay. It is a 7550-1. Now I think that's part of the, it's like the HTC or HCT 733333333333. It's a low dropout regulator, 5 volt regulator. So this is a regulator there. And oddly enough, our DC, and also that's connected to ground, our DC jack, let's just draw it like that. And that is ground as well. Our DC 5 volts that's coming in goes into this regulator, oddly enough. I'm not quite sure why. I tell you what, we'll plug it in a second and we'll just measure the voltage, and we'll then we can figure out what kind of current we're getting through here if we figure out the voltage coming out of this regulator. And then we'll be able to figure out what the charge current is for the batteries. Now, if it is accurate, roughly, that the voltage coming out of the USB is about 20-25 milliamps, then that is the circuit, I guess, which is an odd one, but we'll have a think about it. Let me just get the measurement tool going. Right, let's have a little poke around. I've plugged in the DC cable. There are no batteries installed in this, so it isn't actually drawing any current. That's because there's no path for the current to go down, but we can still measure the voltage. So I think, let's find a ground over here somewhere. I think that center pin should be power. Nope, that one there. So that's the input, it's the top on the output. Right, let's plug some batteries in because I can't seem to read it. So let's pop the battery in there. There we go, now we're drawing a little bit of current, so let's do that. Oh, I should probably turn it off. It might be off, it might be on, I can't tell. So yeah, let's hook onto ground again. I know you guys can't really see what I'm doing here, it's pretty difficult to see it, but so 4.95 volts we're getting, and the display over there reads 0.01 amps, so 10 milliamps roughly. So 4.95. Now that could be because of some internal resistance of the battery. I don't know why I can't read 4.7 before the resistor. And then after the diode, we've got 3.84 volts. And before the diode, 4.15. So the diode's dropping some voltage. So it's possible it's only ever going to get up to 3.84 volts, which would be fine. Like, that's a reasonable charge. Let's have a look at the batteries and see if they're actually increasing. So 3.84. They're fairly fully charged, really. They would get up to 3.5, but I think this actually might be the maximum they'll go up to. So maybe if I put some more discharged batteries in, we'll see what it can actually do. But let's do a calculation on what we think the current would be. So you know what? We won't go for. God, I've ruined all my drawings here. We won't go for what the actual reading was. We'll go for 5 volts. We'll go for the ideal, and then we'll be able to see what the current could possibly be. God, look at it. It's rubbish. So let's break out that old Ohm's law nonsense. Not nonsense, it's useful. So we want to find out what the current is. We know the voltage and we know the resistance. So it is you're going to have to correct me if I'm wrong, because I never learned how to do this at school. So I think it's VIR, isn't it? So that's the Ohm's law thing. So the I is current, we've got voltage and resistance. So we know what our voltage is, and that is 5 volts roughly. And we know what our resistance is, and that's 120. So where's my calculator? I know it's possible to do this in your head, but I can't. So 5 divided by 120 equals 0.04. 0.04 amps. And what is 0.04 amps? That is 40 milliamps. So that's what we're expecting to see. But I guess as the internal resistance of the batteries increases, then it's going to charge less. So the resistance of the whole circuit increases. So that's the maximum it will charge at, 40 milliamps. That's pretty poor. However, NIM batteries, why do I say it like that? Nickel metal hydride batteries need sort of special charging conditions. You can charge them up like constant current for a while, but when they get to a certain point, the voltage will drop and you need to detect that. Also, you need to worry about heat in batteries, especially when fast charging them. Anyway, there's a sort of a detection point with these nickel metal hydride batteries, which is why I've never attempted to charge them fast charge. I've always trickle charged them, or maintain charged kind of thing. It's called something else, not maintain charge. Anyway, so this is 40 milliamps. So what is that out of? So let's do 800. I don't know how to work out a percentage. This is going to be embarrassing. Divided by, well, there's a percent there. Divided by 40. No, I don't know how to do that. 800 divided by 100. So that gives me every percent. And then, so it's 8. And then I do 40 divided by 8. So that's 5%. 40 milliamps is 5% of 800. So that means it's charging at a 0.05 C. Let's have a look. Let's write that down because I don't want to forget. 0.05 C. And C is the maximum capacity, so it's charging at 5% of that maximum capacity. Do you know what? That is roughly accurate for a maintenance charge on a sort of these nickel metal hydride batteries. I would probably be a bit more aggressive and go for 0.1 C. I don't know why I'm rubbing that out. I'd probably go for 0.1 C, 40 milliamps, which, because batteries are cheap and they don't need to last forever, but you do need to charge them quickly. So if I wanted to get, let's say I wanted to get, what's 0.5 what's 5% of 2001? Well, 1,800, the current battery's in there. So 1,800 divided by 100 equals 18. And we want 18 times 5. So 90 milliamps. I don't know how to work out a percentage. I'm not even looking it up. That is accurate though. So 90 milliamps is what I want to aim for, except I don't, because it would still take forever to charge. So I'd go for a bit more of an aggressive charge, double that. So about 200 milliamps. So let's say we want to look at changing this to be 200 milliamps. And that would mean it would charge overnight, let's say. So if I put it on charge, the next day I could put it out again in roughly 10 hours. That sounds okay to me. I'd be happy with that. And I don't think charging it at 0.1C is actually pushing it too much. So if we know we want 200 milliamps, we can do that whole VIR calculation again. So in order to do that, we need to find out what our resistance is going to be. So R equals, what is it, voltage divided by current. We know what the voltage is going to be because it's going to be 5 volts. We don't know what the resistance needs to be. The current we know is going to be 200 milliamps. So we do 5 divided by 200. So 5, you can't see it because it's one of these angled things, divided by 200 equals 0.025. So 0.025. And that is 25 ohms. I believe that's about right, I think. So we need a 25 ohm resistor. I think the problem here is though, this is 1 watt, isn't it? So that's 1 watt. So we'd need to be able to have a 1 watt resistor. That's easy enough to find though. It's an SMD resistor on the board here, so let's see where it is. I don't know if you'll be able to see it because it's going to be out of focus, but it's this resistor just here. Easy one to replace, and I could wire up just a standard resistor across from the diode to the end of that regulator easily enough. But I've just looked up this 75501, and that is limited to 100 milliamps. Which is a bit of a bugger, isn't it? So it's limited to 100 milliamps. That's the most it will give out. So we'd need to find another way. Now, the easiest way I can imagine doing it is just plugging the darn thing straight in. I have no idea why they would put this 75501 in through the DC jack into a 5 volt regulator. I suppose because people might mistake the DC jack for a 9 volt port potentially, so this could drop it down to 5 volts. Still, it's limited to 100 milliamps out, and it's only taking 40 milliamps. So yeah, I could mod this myself, but I don't know. So, well, it's not up to you guys, but I would love to hear what you think. How can I make this better or last longer? I could convert it to a different type of battery. That would also be fine. I'd have to put a boost circuit in most likely for a LiPo battery, but yeah, I'd love to know your thoughts.